All right, in the next section here in Chapter 7, we're going to add to our special types of quadrilaterals. So last week we talked about parallelograms specifically, so different properties involving parallelograms, what they were. Now we're going to add some different types of special parallelograms with their own kind of set of properties that we can use to help solve for missing sides, missing angles, and things like that. And so the first type of special parallelogram is a rectangle. And so if we look at the rectangle, as far as the definition, it is a parallelogram. So that's a really key part of this definition. But we also have a parallelogram with 4 right angles. So if we thought about our parallelograms before, our parallelograms were kind of slanted and they had like parallel sides and congruent sides and things like that. With a rectangle, we're going to straighten up those sides and we're going to produce what we see down here below, where all of the angles are right angles. Okay, and you've seen rectangles before. You've probably worked with rectangles quite a bit, so this shouldn't be really too much new information. But as we're looking at this, some things to think about and things to consider here is that because it's a parallelogram, so when we look at that definition, because it's a parallelogram, it has every property that a parallelogram had. So we had those 5 properties from last week. Opposite sides are parallel. Opposite sides are congruent. So if they tell you this is a rectangle and they say that this top side is 3x plus 10 and this bottom side is 7x minus 20, and they say what is x? Well, because it's a rectangle, opposite sides are congruent. And so it's just like when we worked with parallelograms, everything that a parallelogram had, so does a rectangle. And so all 5 of those properties, which you should know by now, apply to a rectangle as well. Opposite angles are congruent, diagonals bisect each other, all of that. Now, as far as a rectangle specifically, though, a rectangle has 2 specific properties that it brings to the table. And if you're keeping track of a sheet of paper with all the properties, this is what you want to add to that. So under your parallelograms, I want you to add rectangles, and then I want you to add these 2 properties. So 4 right angles, so that's what we talked about just a little bit ago. All 4 corners or vertices are right angles. And then the other big thing is that the diagonals are congruent. So when I look at this picture here and I highlight my diagonals, so B to D and A to C, okay, when we look at those, we can see that we have this statement down below here, AC is congruent to BD. So the whole diagonals are exactly the same. Now, not only that, but we already talked about the fact that we have every property a parallelogram has, and parallelograms have their diagonals that bisect each other. So what that tells us is each of these 4 pieces in the rectangle has to be exactly the same. So not only are the entire pieces the same, each individual part is congruent to each of the others. So with rectangles, the big thing is adding in this idea that all 4 angles are right angles and the diagonals are exactly the same. So if we look at applying a couple of these properties here, if we have a rectangle, so quadrilateral MNOP is a rectangle, so that's a key piece right there. It says MO, so that's this entire length right here, is 2x minus 8, NP is this entire length right here is 23. Well, we just got done talking about the fact that the diagonals are congruent. So that means if I want to figure out what x is, I'm going to take 2x minus 8 and set it equal to 23. The diagonals have to be exactly the same. And so then if I go and add the 8 to both sides, 2x would equal 31. And then if I divide both sides by 2, x would equal 15.5. And so there's my value. So if they tell you it's a rectangle, diagonals are going to be congruent. Opposite sides are going to be congruent. Opposite angles are going to be congruent. So it has all the things that parallelograms have, plus those 2 new bonus properties. Another one here works with the angles. So if we're looking at the angles in a rectangle, so again, it says what we're using a rectangle. We know that each of the corners is 90 degrees. That's going to be a really key piece here. So each of these corners total is going to be 90 degrees. Now they're telling us that the measure of angle 1 is 70. So this angle right here is 70 degrees. They want us to find angle 2, angle 5, and angle 6. So if I'm looking at this picture here, angle 2 is right next to angle 1, and we know that we just marked here that the entire corner has to be a right angle or 90 degrees. So if angle 1 is 70, I can subtract that from 90, angle 2 would have to be 20. Okay, so that's one of our angles that we were missing. For angle 5, what we have to do is angle 5 is down here. Now angle 5, if we think about this rectangle, it has everything parallelograms have. That means this top side and this bottom side are parallel to each other, which means I have alternate interior angles with 1 and 5. And so angle 5 would have to be exactly the same measure as angle 1, or 70 degrees. Likewise, for angle 6, I could either subtract from 90 and get my 20, or angle 6 and angle 2 are alternate interior as well, because the sides here are parallel as well. So the fact that it's a rectangle means it's also a parallelogram. It has all the same properties. Now, they only asked us to find 2, 5, and 6. But at this point, we can actually find all the angles in here. Because what's going to happen here is, with these opposite sides being congruent, and with our alternate interiors and things like that, what's also going to happen is we have these diagonals that are all congruent. Which means I have 4 different isosceles triangles. This triangle that I highlighted in green here is isosceles. I have this side and this side congruent, which means if angle 5 is 70, angle 4 is 70. Or if I come over to the side here and I highlight this triangle on the left, this triangle on the left has these two sides marked congruent, which means if angle 6 is 20, angle 7 is 20. And then I can go through and fill in the rest. We got 70 here, 20 here, and even at that point I can find these middle angles because I have this triangle where I know 20 and 20 are my 2 angles. If I subtract those from 180, angle 9 is 140, which means angle 10 is 140 because of vertical angles. Or on the other side then, the linear pair here tells me that this angle is 40, and then this angle would be 40. So what's nice about rectangles is if they give you one single angle anywhere in the picture, you could find any other angle as well. Now typically we won't do that, we'll just have you find like we did, find this angle, and this angle. So it's going to be a little bit simpler process, but all of those relationships still exist, and you need to be aware of the fact that those can happen. Okay? So that's rectangles. Let's switch to rhombuses. So a rhombus is another type of special parallelogram. And again, if we look at the definition, it's a parallelogram, which means it has all 5 properties that parallelograms had. So everything that the parallelogram has, the rhombus is also going to have. So opposite sides are congruent, opposite angles are congruent, and things like that. But the rhombus is going to bring some new stuff to the table. So first of all, in the definition, it has 4 congruent sides. So for a rhombus, as we see in the picture marked below, all 4 sides are exactly the same. And so here, if they tell us that one side is 10, all sides are 10. Or if they said this side here is 4x minus 4 or 5, and this side is 3x plus 20, even though they're not opposite sides, it's a rhombus, so all sides are the same. So I can just take the 4x minus 5, set it equal to the 3x plus 20. Now, besides that though, what we also bring to the table with a rhombus, we see down here. So 4 congruent sides like we just talked about, but then there's also 2 more properties. The diagonals are perpendicular. So when I draw my 2 diagonals in the picture that we see here, they're going to meet at right angles. And really what's going to happen then is if that angle is a right angle, all 4 angles in the middle are right angles. So every time you get a rhombus, if they put those diagonals in, those middle angles are always going to be 90 degrees. The other thing is that diagonals bisect opposite angles. So what we mean by bisect again is cut in half. So if I'm looking at this diagonal right here from D to B, what's going to happen is when I put that diagonal in, it's going to take angle B and cut it exactly in half. Those 2 pieces are going to be identical. And down here at angle D, they're going to cut each other exactly in half. And since opposite angles were already congruent, these 2 angles up top are going to be exactly the same as these 2 angles below. Same thing with the other diagonal. If I put in my other diagonal from A to C, I'm going to cut angle A in half, and I'm going to cut angle C in half. So So I'm going to cut both of those opposite angles in half. And then again, because opposite angles are already congruent, all 4 angles we create are congruent. And so with our rhombuses, typically we kind of work with the angles more so than the sides, because we talk about the sides with rectangles and parallelograms and things like that. So they want to talk about some of the angles because those are a little bit more interesting with rhombuses. So as far as the examples that you see here, it says find the measure of the numbered angles in each rhombus. So as I'm looking at this picture here, the first thing I notice is that this angle is 100 degrees. And as I'm looking at the picture then, it's a rhombus, which means it has everything a parallelogram has plus the 3 new properties. And so that means opposite angles must be congruent. So that means the measure of angle 1 must be 100 degrees. So this piece right here is going to be 100 degrees. Now, if we think back to parallelograms, in parallelograms, consecutive angles had to add up to 180. So if I'm looking at this picture here, this angle that I have here, 100, would have to be supplementary to this entire angle here. The angles next to each other are supplementary. So that means that the entire angle all the way across here would be 80 total degrees. But I don't want the whole angle because we have a diagonal drawn in. So they have this diagonal cutting right through the middle of it. And since we said that the diagonals bisect those opposite angles, what that means is I'm going to take that 80 degrees for the whole angle and I'm going to make it 40 degrees for each piece. And so the measure of angle 2 is going to be 40. That also means my opposite angle, so when I come over here, my opposite angles are also going to have to be 40 degrees. So there's my measure of angle 3. And so when we're working with these special parallelograms, we have to keep in mind that not only do we have the new properties, we also have to remember the olds. The opposite angle is congruent, the consecutive angle is 180, the opposite side's congruent, and things like that. Now if we take a look at the second example here, right away, if I see a rhombus with both diagonals drawn in and I'm looking at angle measures, the first thing I would always do is label the middle. The middle always has to be 4 90-degree angles. So as soon as the 2 diagonals are drawn in for a rhombus, those middle angles are all 90 degrees. So measure of angle 1, 90 degrees right there. Now from there, the other thing we can do here is we see that this 40-degree angle is given, and since the diagonals cut angles in half, that means this piece would have to be 40 degrees. Opposite angles are congruent, so that means this side has to be 40 degrees each, and there's angle 3. Now to find angles 2 and 4, we're going to have to go back to an idea that we involve using triangles. So in my triangles here, if I look at this triangle right here, I know that the angles inside this green triangle have to add up to 180. So if I take 180 minus my 90 and 40, that leaves me with 50 degrees for angle 4. And as soon as I know that angle is 50, that means the angle across from it's 50, and then our opposite angles are each going to be 50, and so there's angle 2. Okay, so when you're working with these rhombuses, again, it's kind of like the rectangle. If I know one angle, I know any other angle in the picture using my opposite angles, using those right angles in the middle, or using my triangles to add up to 180. So be able to kind of work with those and find those missing angles there. Now the square is kind of the most interesting one because the square has everything. So literally every property we've discussed to this point, a square is going to have. So as we can see, it shares all 5 properties with a parallelogram. Opposite sides congruent, opposite sides parallel, opposite angles congruent, and things like that. We also see that it has the 2 properties that rectangles had. So 4 right angles, diagonals are congruent. And it also has the 3 properties that rhombuses had. 4 sides congruent, diagonals are perpendicular, diagonals bisect opposite angles. And so with a square, we can literally apply anything that we've had to it. So if I were to take this picture where I have my 4 right angles and I have my 4 congruent sides, I would need to, if I put in my diagonals here, I would need to understand that each of the pieces that I just created would be congruent. The diagonals are congruent, they bisect each other, so all the 4 pieces are congruent. I also know, because it's a rhombus, that each of these inside angles is 90. I also know, because it's a rhombus, that I'm going to cut these 90-degree angles in half, and so each outside angle is going to be 45 all the way around. And then from there, I can use that to solve for whatever I need within the problem. Now, what's important to note here is that when you're working with these quadrilaterals, and it's going to, like, you're going to get some problems that say, here's a rhombus, find the missing piece, or here's a rectangle, find the missing piece. There's also times where they're going to give you a shape and they're going to say, what is this? So is this a parallelogram? Is it a rhombus? Is it a square? And things like that. And so if we think about this while we're looking at all these properties, if I can only show one of these properties from the top, so in red here I'm going to say if I can only show one of these properties exists, then the best I can do is call it a parallelogram. But if I could go a step further and maybe I could show that it has 4 right angles, or it could show that it has diagonals or congruent, then I could actually go a step further and say, oh, now it's a rectangle. Or from that parallelogram, I could come down and say, well, it has 4 congruent sides, or it has diagonals or perpendicular or whatever else, and now I can go down to a rhombus. Now the square is the toughest. The only way I can say that something is a square is if it has something from rectangle and something from rhombus. So it has to have 2 pieces that go with it in order to become a square. And so I have a little organizational chart here to kind of help us think through this. Again, we kind of work our way down. We start by assuming it's a quadrilateral. So it's got 4 sides, at least it's a quadrilateral. If I could show any of the 5 properties of parallelograms, then I can move to the next level as a parallelogram. Now the next level, rectangles and rhombuses are at the same level. From a parallelogram, if I can show a property from rectangle, then I move that direction. Or if I can show that it has a property of a rhombus, I can move that direction. Now, if I were able to show that this rectangle property and this rhombus property were both in the picture, then I can go even further and go to my bottom level of square. And so another way of looking at this is kind of with a Venn diagram like we see here. And so again, we kind of work from the outside in. So we start with a quadrilateral. If I can show one of these properties, then I can move into parallelograms. If I can show that it's a rectangle somehow with one of the 2 properties, then I move into rectangle. If I can show that it goes into the rhombus or circle, I can go into there. And if I can show that it goes to both, then I can come in here to square and call it that. So what you have to understand here is that we kind of work our way down the steps. So we start with quadrilateral and work our way down depending on the information given in the picture. Now the other thing to note here, and I'm going to come back to this chart here, is we can always move down with more information. So a quadrilateral can become a parallelogram, can become a rectangular rhombus, can become a square. But as I'm looking at this, every rhombus that I find is also a parallelogram or is also a quadrilateral. But just because it's a rhombus doesn't mean it's also a square. It doesn't go down in terms of always going to be that. A rhombus can be a square, but it's not always going to be. It can just be a rhombus and that's it. But it's always going to be a parallelogram. It's always going to be a quadrilateral because we've already established that. And so it's really important that you understand we have to work our way down in terms of what we are. So we start at the top and we can work down if we get more and more information. We can't work back up from there. Okay? So with that, you should be able to complete the worksheet that you got in class today or that you get off of Google Classroom. Make sure that you ask questions as you need to. Make sure you check the answer key when that becomes available, and then just make sure you have it finished in time to turn in when we go to collect it.